Hello everyone. Today we're going to be talking about the global water cycle, and we're going to get into the idea of fluxes and reservoirs and the importance of understanding the volume of water that's being moved in the water cycle. So to give you an overview, or the big picture so to speak, of all the water on Earth, 97% is locked up in oceans. And that water is unable to be used by humans and is unsuitable for human consumption because it has such a high salt content. So of the 3% that's left over, that be used by humans. Roughly 30% of that water is locked up as groundwater. Around 68 to 69% is ice caps and glaciers. And that remaining 1% is actually fresh water that's surface water. And that's the water that we tend to use for human purposes. Of that 1% of fresh surface water, 87% is locked up in lakes. Around 11% is in swamps, and 2% is in rivers. Here's just another graphic to show you the breakdown of that water again. So if you look at the dark kind of green colored water droplets here, that is all salt water. And then you get down here to this 3% that is fresh water. You can see those two right here, that's mostly fresh water, but that's locked up as ice caps or as groundwater. And then that one little leftover raindrop is the easily accessible water. And that's where, like I said before, where we get the majority of our water for human consumption. So I just want to bring to your attention a couple key terms that we use when we talk about water cycles. One of those is a flux. And so what a flux is just the movement of water from one reservoir to another. So if you look at this picture here, a flux would just be things such as evaporation that you see here, or rain that you see here, or snow here. And it can also be things like sublimation or advection between clouds. So our next term is a reservoir. And a reservoir is just a place of extended residence of water. So anywhere that water stays for an extended period of time. And those things could be groundwater, so aquifers. They could be streams. They could be oceans. They could even be clouds. Also important in the water cycle is the term volume. So volume is just how much water is either stored in a reservoir or that is moved through a flux. So if you ever draw a water cycle or you are talking to someone about a water cycle, it's important to understand not only the flux in the reservoir, but actually how much water is actually being moved through those two areas. This is just another example of a water cycle. You can see different fluxes. So you can see precipitation here. There's actually several precipitations. And you can also see evaporation happening. And you can see how the volume of those fluxes change, whether they're over the ocean or whether they're over the mountainous areas here, or whether they're more inland over lakes or any other type of area. This also shows you different reservoirs. So like I already mentioned, the lakes here. You can see reservoirs here of rivers, and you can also see groundwater here and oceans. So this shows you your flux, your reservoir, as well as the volume of water that is being moved. This is another good example of a water cycle. It shows a river, it shows the ocean, so some precipitation that's happening, evaporation that's happening. It even shows you snowfall. Here's water vapor that's being absorbed through evaporation over land. It also gives you the amount of water that's going through all of these fluxes and in these reservoirs. And it shows you a very important part that, let's go back, that was not shown on this water cycle. Now if we look at this, the important part that was missing on that previous water cycle slide was humans. Now, humans are a huge part of the water cycle, but they're often left out of drawings or not really discussed. And that's something that we really want you to get out of this course, is the fact that humans have altered the water cycle to benefit themselves. And if you look, they actually have altered the water cycle a lot. So if we had just regular grasslands or wetlands, like you can see on this map, those are reservoirs that hold a lot of water or don't hold a lot of water with grasslands. But when we come in and we alter the water cycle for ourselves, we're taking the water away from those areas and putting them into our homes. So water for drinking, water for waste, all of those things, as well as for industry. So when you are thinking about the water cycle, don't just think about the natural components like evaporation, precipitation, groundwater flow, river water flow, but actually think about what impact humans have on that global water cycle. So this is just showing you how long water stays in any given reservoir over what period of time. So if we look water in the atmosphere, it stays there about 1.5 weeks. In river channels, around 2 weeks. And then we can go things like ice caps for 1,000 years or groundwater. Groundwater has a residence time of anywhere from a couple hours, 2 weeks, all the way up to around 10,000 years. So when we're thinking about the water cycle, we also need to think about how long that water stays in those reservoirs before it goes on into a different flux or into a different reservoir. So one of the big parts of the water cycle that we think of is precipitation. So precipitation is a flux, and precipitation isn't just when it rains outside, but it's rain, snow, sleet, ice, anytime there's water in any form falling from the sky. Now, anytime there's water vapor in the atmosphere that condenses around dust particles, that forms precipitation. And when clouds become too full of that water vapor, they begin to rain. Around the globe, yearly, around 15 million gallons of precipitation fall. So after water falls from the clouds, it hits the land or becomes surface runoff via through fall, where it's intercepted by plants. And it can also move into the Earth's surface and become groundwater flow. So there's several different types of groundwater flow, but two important ones are percolation and infiltration. So infiltration is anytime water soaks into the ground from the surface. And percolation is just water moving through rock or any other ground layers to the saturated water table. So infiltration is just water soaking into the ground from the surface, and percolation is that infiltrated water moving through the ground and entering the water table. So that brings us to groundwater flow. Water is considered groundwater if it is flowing underground in the saturated zone. This can also be referred to as the water table. And water will generally flow through the ground to a stream. It can also be pumped out of water via wells. And there are also areas of groundwater where there's either recharge or discharge happening. So recharge happens when the water has low saturation, and discharge happens when the groundwater has high saturation. So recharge is happening when the water table is low, and discharge is happening when the water table is high. So when a water table is high and, like we talked about here, discharge happens, that could also lead to surface runoff. Other things that lead to surface runoff are precipitation. If so much precipitation happens that infiltration cannot occur anymore because the ground is saturated, then overland flow or surface runoff will start to happen. This can also happen because soils are too dry, or again, soils are too saturated. And runoff quality or quantity is really affected by surface cover. So if in an area that has more vegetation, the surface runoff would be lower because the plants are helping absorb that water than in areas such as the parking lot of the local supermarket, where the ground is unable to absorb the water, and so the water just runs off of that surface. Next, we want to just mention water vapor, and we jokingly call this the tale of two processes. So we have evaporation, and that's anytime water, it's a flux, and it's anytime that water comes from bodies of water or soils. Primarily this happens from the ocean because that's the largest body of water that's on the earth. Evapotranspiration, on the other hand, is any times that plants lose water. This is when plants when they open their stomata, they lose water out of that, and plants cannot control this process. So we just want to look at this map here for a second. And so this is just showing the global evapotranspiration. So like we told you in the previous slide, evapotranspiration is just the loss of water from plants. So if you look at this carefully, you can probably see some trends happening. One being that there's a lot of evapotranspiration occurring here in the rainforest areas here around the equator. And there's not a lot of evapotranspiration going on here and here in Africa where the desert is. So evapotranspiration does change depending on the amount of plant coverage there is. So if we want to take a look at this map here, this is just the global water available on Earth. And if we take a look, we can see that areas where there is high evapotranspiration, so the rainforest here again, we can also see that there's a lot of water available. And in areas such as the desert here in Africa, there's not a lot of water available, and there also was not a lot of plant life. So if we want to take a look here, this is just a map showing us how much water is available in all of these different countries. So countries, again, such as here in Africa, where there's lots of deserts, are actually water scarce, if you take a look there. And then we can take a look at these other places. So like Canada is not water scarce at all. They have lots of snowpack. And again, we can see here in South America, these countries here are not water scarce. They are also not vulnerable. They actually have lots of water available to them. So what's next? So next week we are going to actually talk about the distribution of water on Earth. So we're going to talk a little bit more about where water is, why it can be found in those places, and what they use that water for. So I hope you enjoyed this and have a good night.